So welcome. My name is Manny Barbera. I'm one of the vice presidents here at the Silicon Valley Education Foundation. I'm a retired superintendent from the Oak Grove School District. And very happy to have you here. Just a little bit about the foundation, and I'm sure there's some information, hopefully you saw it when you came in. We focus on supporting districts, on helping students become ready for post-secondary success, and we particularly emphasize completion of the University of California CSU A to G requirements. And we do that a couple of ways. One is through advocacy, through like forums like we have here today. We work with districts. We've got a major project going on in the East Side community on this very topic today, placement. We have an outstanding blog, if you've not checked it out, called Thoughts on Public Education, Top Ed, which our primary writer, one of them, John Fensterwall, formerly from the Mercury News. We added Kathy Barron. If you've not had a chance to check it out, seriously, please do, because it is, I think, at the forefront of blogs and education news. If you haven't been keeping up what's going on in education, you can easily do it by reading John and Kathy's blog. We also have guest contributors as well. What I'm going to do first is I'm going to first introduce our EdSource team, and then I'll introduce the panelists. And first, I will start first with Matt. So Matt Rosen is the Senior Research Associate at EdSource since 2007 and responsible for publication, research, writing, and project management. And a lot of his work focuses on issues and transitions through the middle grades. We have this information, so you can read this. I particularly like, Matt, that you have degrees in philosophy. So both a BA and a master's. So later on, Matt will look into your souls if you like, and have a conversation. So thank you for being here, Matt. Really much appreciate Matt Rosenbein. He's a Teacher Research Associate. And the person I'm going to introduce now is Mary Perry, and she is the Deputy Director of EdSource since 1993, and known for expertise in school finance. She was the Steady Project Director for collaborative partnership between EdSource and school services under the auspices of Getting Down to Facts. She's the Senior Publications Writing Manager, Editor of all EdSource publications. How many of you have read anything from EdSource? Yeah, right? It's great stuff. So this is the person to acknowledge and to thank. So today, they're going to be talking to you about this extremely important study called Preparation, Placement, and Proficiency Improving Middle Grades Math Performance. And one of the ways that we wanted to help reach out to the education community, the foundation, is to bring the actual researchers over to you. So please welcome both Matt and Mary Perry.
So what Manny didn't tell you is my kids went to Del Mar High School. So that's exciting that project's going on. I just want to start by telling you a little bit about the larger study that we did on middle grades, give you a little bit of a context and explain a little bit about the research we did, just so you understand both what we were trying to figure out and the limitations of that. And the studies were actually supported by the S.D. Bechtel Jr. Foundation and also by Reed Hastings, who is the CEO of Netflix. So, Gaining Ground in the Middle Grades was a study that we released in February of 2010. And we conducted it with partners from Stanford and also the American Institutes for Research. We had a really basic research question. What we knew is that schools serving similar students had really pretty wide ranges of student performance on the state's standardized tests. So, we all understand that student background has a strong correlation with student performance. But when you look at schools where the kids are the same and the performance is quite a bit different, what's going on? And that's what we wanted to try to figure out. And specifically, what we wanted to know is what the higher performing schools were doing either more intensively or just in general than the lower performing ones. So, we surveyed schools. We had 303 schools, and we had a ridiculous number of survey questions. We asked principals, we asked the teachers, the math and English language arts teachers in those schools, and we also asked superintendents whose schools participated. A whole series of questions. They had to be at least serving 7th and 8th grade, and we looked at every middle grades configuration. We had K-8 schools, 6-8 schools, 7-8 schools, so that we really got a sense for what was happening to middle grade students. This was not a middle school study, it was a study of middle grades. And specifically what we wanted to do as far as the performance measure was to find something that was a common measure. Well, pretty much in California, that means using the California Standards Test. And so what we did was to look at English and math CST scores for the 6th, 7th, and 8th grade students in our 303 schools. And we know that tests are not the only measure of a school's performance, but they are something that's common, and we felt that it was a way that we could learn something about the relationship between the practices that the educators reported in their surveys and the performance of their students. And we felt like we did learn something. The study identified a really coherent set of practices that set the higher performing schools apart from the lower performing ones. The analysis examined the differences in reported practices among schools, as I said, and the intensity with which they reported it. So sometimes the difference that we saw between lower and higher performing was, we always do this, versus, well, sometimes we do this. Or 80% of teachers said yes all the time, and in another school only 30% said so. So there are lots of ways to measure intensity, and it was an important part of what we looked at. But the study itself provides a lot of specifics about what district schools and classroom practices are in these higher performing schools. The other thing that we think makes it really important is the focus on middle grades. There aren't that many studies that have been done on middle grades. I can tell you that part of the reason is because they are very complicated to try to study. Elementary schools are kind of like all elementary schools, right? But just even the configurations in middle grades make it really hard to do what researchers call quiet down the noise, so that you can really look at something and figure out whether or not there's a correlation and a difference. And so we were really excited about having as many schools as we did in the study, and about what we learned. And specifically what we learned was that higher performing middle grade schools have superintendents, principals, and teachers who all reported intensely on these things. And the first and foremost of the practices was accepting and sharing accountability for results. And further, those results being about academic expectations and high academic performance. One of the interesting things about the accountability information was the extent to which it wasn't just a question of superintendents and principals and teachers, but also that there was a concerted effort to make sure that parents and students also felt accountable for high student achievement. And that's a whole strand in the larger study that we have found educators are very interested in, and we thought it was very interesting. These schools make students' academic success and their future the core focus, the most important thing that happens at the school. They set measurable objectives for every student, and they also get together and really understand what they're doing with their curriculum. Things like selecting key standards and cross grade level meetings as well as grade level meetings, those kinds of things. They use data a lot. They also use and one of the things, the most important things they use the data for is to identify early kids who are having challenges and issues, and making sure then that they figure out what to do in terms of interventions to help get those kids what they need and get it for them early. And the other thing is that they do ensure a positive climate for student learning through a variety of things. So, we released that study in February of 2010, and we knew that we had to dig deeper. We had data from over 200,000 students. We got a longitudinal data file from the Department of Education that followed kids from 7th grade forward, or I'm sorry, from 5th grade forward.
Depending on
6th
which,
grade, yeah.
basically 4 years.
4 years of data for these kids, okay? And so we really had a lot of information. And about the time we started this study, the state board made a decision about 8th grade algebra that some of you in the room probably remember. So here we are starting a study on middle grades, and 8th grade algebra is like the hot topic in California. So one of the things we did was to make sure that we got lots of questions in that were about how kids were placed in algebra and so forth. And after we finished the main study, we turned around, I think it was 2 weeks later, and started work on the analysis that Matt is going to tell you about.
My name is Matt Rosen. I'm EdSource's Senior Research Associate. I'm going to tell you a little bit about what we learned about Algebra 1. And as Mary mentioned, we had this longitudinal data file. When we get, which was really important because when the CST results are released by the state every August, there's a lot of information that we can glean from those things about Algebra 1 and grade 8. For instance, we can see what percentage of students are taking the Algebra 1 test. We can see how they're doing on that test. And over time, we have seen improvements in both the percentage of 8th graders taking Algebra 1 and the percentage of 8th graders are scoring proficient advanced. So there is unequivocally a success story there in terms of the work that educators in California are doing to meet this standard. But at the same time, there's other data that is part of these same results that get released every year in terms of the large numbers of students that are scoring below and far below basic and so forth. And one of the things that this slice of time data that we get each year doesn't tell you is, well, how students did earlier relate to how they were placed, relate to how they did in grade 8, and so forth. And that's an additional extra layer that's important to get at. And we were really lucky that in doing the Gaining Ground study, we had this longitudinal data file. So the centerpiece of what I'm going to tell you about is an analysis of this longitudinal data. And in particular, I want to tell you about 70,000 8th graders that were part of our sample. And there are two really important things we know, well, three, that we know about these 8th graders. One, we know that in 2008 they took the grade 7 mathematics CST, so that grade level test. These weren't 7th graders that were already taking Algebra 1. They were taking that grade level test. Moreover, we knew that the following year, in 2009, which was our study year, that these 8th graders either took the Algebra 1 CST, which is the test you take if you're positioned to complete a full Algebra 1 course, aligned with the Algebra 1 standards, or these 8th graders took the General Math CST, which is a test that tests primarily grade 7 and some grade 6 content that you take if you're not yet positioned to complete Algebra 1. So in effect, what that difference gave us was, in effect, a measure of who was placed in Algebra 1 in grade 8. And moreover, we knew what students' test scores had been in grade 8. So that enabled us to dig a little bit deeper about how did placement relate to how you did in grade 7, and how you actually performed in grade 8 relate to how you did in grade 7. So let me tell you first a bit about how these students had performed in grade 7. So these were the 70,000 8th graders, and let me kind of explain this table here. What you've got down the leftmost column there are the 5 performance levels that we're all very familiar with in California. Far below basic through advanced. And we actually broke basic and proficient into 2 different levels to try and get a little bit more of a more nuanced look at these levels. This may be a little bit small, but if you look at page 3 or 4, I think, of the page 4 of the report, you'll find this chart there. We were aware of various efforts to, for instance, try to move students from high basic one year into proficient the next and so forth. So we wanted to take a more nuanced look. So that middle column is the performance levels we looked at for students as they had done in grade 7. So far below basic, low and high proficient, and advanced. And as you can see, the incoming achievement of these 8th graders varied widely. About a quarter of students that were in our sample had scored below or far below basic on the grade 7 test, so about 1 out of 4. Another 13% were at the other end of the spectrum, having scored advanced as 7th graders. And the rest were fairly evenly distributed across the low basic through high proficient levels. So this raised the first big question for us. Given this wide variation in terms of how these students actually did in grade 7, what proportion of students at each of these different levels were actually placed into Algebra 1, which again we were measuring in terms of did they take the Algebra 1 test rather than the general math test? And the answer to that question is here. So let me explain this chart to you. Along the x-axis, along the bottom there, running horizontally, you've got those same seven grade 7 performance levels. So that 27% that's plotted all the way at the left, those are the students that scored far below basic in grade 7. And as you move to the right, you move to the students that had scored advanced in grade 7. Now on the y-axis, what we're graphing is what percentage of 8th graders in each of these grade 7 levels took the Algebra 1 CST rather than the General Math CST. So in other words, given how you did in grade 7, what were your chances of being placed in Algebra 1 in grade 8? That's the question this chart is answering. And as you can see, perhaps not surprisingly, better prepared students were more likely to be placed in Algebra 1 in grade 8. You can see the way the line moves up there, extending all the way up to 95% of those 7th graders that had scored advanced in grade 7 took the Algebra 1 CST as 8th graders. But notice also how frequently the least prepared students were placed into such a course. For example, among those who had scored far below basic as 7th graders, 27%, slightly more than 1 in 4, took a full Algebra 1 course. About a third of those who had scored below basic in grade 7. Now, moreover, one thing that Mary didn't mention was that in our sample of these 303 schools, one thing that we made a point of doing was we had roughly about half the schools served predominantly low-income students. And roughly the other half of schools served predominantly middle-income students. And we were familiar from various reports and things that had come out, one of which was timely at the time when we were starting the Gaining Ground study, the misplaced math student that Tom Lovelace had put out through the Brookings Institution. There were questions about, do schools serving students of different demographics and so forth, are they making different kinds of policy decisions around Algebra 1? And this was something that we wanted to see if we could see. Are the schools serving predominantly lower income schools and our students in our sample doing pretty much the same thing as the ones serving predominantly middle income students, or is there a real difference? And as it turned out, there was a real difference. So let me tell you first which group of schools is which. So this is the same chart as before. You've got the same grade 7 levels going across the x-axis. And again, we're still graphing what percentage of students at each of these levels took Algebra 1. But we're graphing two groups of schools. So the orange diamonds along the top, those are schools that are in the 20th to 35th percentile of the School Characteristics Index, which is this measure that California has to help compare similar schools for accountability purposes. And those are the schools that serve predominantly lower income students in our sample. By contrast, the brown or sort of tan circles there, those are the schools that serve predominantly middle-income students. They're located in the 70th to 85th percentile of the School Characteristics Index. And as you can see, the difference between these two groups of schools is fairly striking. And there are a couple different interesting stories here. One is perhaps most striking at the lowest 3 levels of grade 7 performance. At each of the bottom 3 levels of incoming student preparation, students in the mostly low-income schools were roughly twice as likely to be placed in Algebra 1 as were similarly prepared students in the mostly middle-income schools. So, for example, among those who had scored far below basic as 7th graders, 15% versus 32%. Among those who had scored below basic, 21% versus 39%. And among those who had scored low basic, 32% versus 59%. So there are some real differences in policy that we're seeing here. But moreover, it's also notable to note that the mostly middle-income schools as a group were fairly conservative even at the high end compared with the schools serving mostly low-income students in terms of placing 8th graders into algebra. So for instance, if you look at students who scored high proficient in grade 7, so they were in the upper part of the proficient range, not the lower part, but the upper part, closer to advanced. At this level, 92% of those students in the mostly low-income schools were placed in Algebra 1, compared with only just a little bit more than 3/4 in the mostly middle-income schools. So again, there are some real differences in policy that we're seeing here. Now, of course, none of this matters if everybody does equally well when they get into Algebra 1. So the next question that we had was, how did students fare in grade 8? And remember that we knew not only what their scores were in grade 7, but what they were in grade 8. So what we wanted to know was, does everyone have an equal chance of success in Algebra 1 regardless of their preparation or not? And the answer to that question is on this next chart. And this, I assure you, is the most complicated chart you'll have to look at today. So let me explain this one. The x-axis along the bottom is those same grade 7 performance levels. So the students who scored far below basic in grade 7 all the way to the left, and those who scored advanced all the way to the right. But we're graphing something a bit different this time. This time we're graphing what percentage of students at each of these levels scored proficient or higher on the CST they took. And recall that students at each of these levels took 1 and 2 CSTs. So for instance, let's just talk about students who scored far below basic. If we go back a couple of slides, 33% of these students had taken the Algebra 1 CST, and the rest took the General Math CST. So what this chart's telling you is that among students who scored below basic on the grade 7 test and went on to take the Algebra 1 CST, only 3% of those students scored proficient or higher on the Algebra 1 test. By comparison, among those roughly 2/3 of those students who took the General Math CST, 8% of those students scored proficient or advanced on the General Math CST. And it's the same form of reasoning as we move through. So for instance, among those who scored high basic in grade 7, if they took Algebra 1, 20% scored proficient or higher. Whereas if they took the General Math test, 56% scored proficient or higher on that test. Now, this is fairly complicated data, but you see the way we've kind of color-coded the backgrounds there. We really think we see 3 different stories here. The first is about the most prepared students, so those who scored high proficient or advanced in grade 7. These students generally scored highly regardless of which test they took. Although note that even at the high proficient level, you still have a little bit more than 1 in 3 that don't score proficient or higher in Algebra 1. But by and large, these students do pretty well, including in Algebra 1. The students in the middle, those who scored high basic or low proficient in grade 7, are frankly a really complicated case. If placed in Algebra 1, these students generally achieved at least the basic level, but as you can see here, they generally didn't score proficient or higher. So depending on whether proficient is your preferred benchmark for what counts as success in Algebra 1 or basic, there are a couple different ways in which you can look at this. And they're both defensible, it just depends on what your goals are and what you're trying to achieve. But the General Math CST, by and large, appears to pose too little challenge for many of these students, particularly those who had scored low proficient. Among those who took the General Math test, which was a minority of them, as you'll recall, 82% of those students scored proficient or higher. Of course, you would have liked to have seen more, but by and large, many of these students may have been up for a greater challenge, at least to the extent that, at least as represented by the General Math test. Finally, things get a little bit more cut and dried again when we get to the least prepared students, so those who scored low basic or lower. These students were very unlikely to score highly on either test, and those placed in Algebra 1 generally did not even reach the basic level on the Algebra 1 CST. Moreover, what's really interesting to us that is perhaps reveals a bit more information is those dark orange bars, the ones who took the General Math test. These students, if they weren't placed in a full Algebra 1 course, were unlikely to score proficient or higher on the General Math CST, which, again, recall, is primarily grade 7 content and some grade 6. So it's a lot of the same stuff they were tested on the year before, and they're still not reaching the proficient level on much of that same content. So what we think this is telling us is that there's a group of students here in our sample that are continuing to struggle with some of the same content and are not mastering some of the foundational content that you'd want them to have to succeed in a full Algebra 1 course, which, as you can see, when they're placed in one of those, they have very, very small chances of scoring certainly proficient, but they generally don't even score basic. So we think the main takeaways from this are this. The placement in Algebra 1 for the state's most prepared math students appears to be serving them very well. By and large, they do pretty well in that course when they get placed into it, at least as measured by the Algebra 1 CST, which admittedly is a really limited measure. It's not all the information that a school or district would have about students. It's not benchmark tests. It's not things that are happening every day in the classroom. But it is one measure. And in addition, some students score really well on the Algebra 1 CST despite having relatively low prior year scores. So if I go back a slide, think about those that 3% of the students who scored below basic in grade 7 were placed in Algebra 1 and then scored proficient or advanced on the test, or that 11% of students in the low basic category. Unfortunately, what I can't tell you is if there's anything systematically different about those students, if they're getting some particular kind of support, or moreover, I don't even know what curriculum they're taking. General math is just a test. That it simply means that you're not in a full position to complete a full Algebra 1 course. You could be in the first half of a 2-year Algebra 1 course. You could be taking Algebra Readiness. You could be doing a pre-algebra course. You could be doing any number of things. So I don't know if there's a consistent story about those students, but there's questions to ask and quite possibly some important knowledge to still be gained here. But unfortunately, we don't have the answers for that. But finally, a one-size-fits-all approach of placing all 8th graders into Algebra 1, regardless of their preparation, clearly sets up many students to fail, even though their prospects could be predicted, at least in broad strokes. And again, it's only a single kind of measure based on their 7th grade CST scores. Now, that doesn't necessarily mean that Algebra 1 in 8th grade isn't a valuable goal, but what this is telling you is that there's no substitute for strong preparation when you get there. Now, finally, I want to talk a little bit more about what we learned about practice and policy. Mary mentioned that we had surveyed 303 principals, nearly 4,000 English language arts and math teachers, and district superintendents about a range of policies. And because when we started the Gaining Ground study, Algebra 1 became such a hot topic, we were careful to try and ask a lot of questions. In retrospect, there are more questions I wish we'd asked, but we covered a lot of ground. And given the tremendous importance of placement decisions for students, as you can tell from the data we've just looked at, we were struck by some of the results. And now I'm just going to talk about some survey results, basically what people said they were doing. So, given clearly what the consequences can be for students, one thing we were struck by was that, by and large, district superintendents reported that their districts did not have explicit or written placement criteria for Algebra 1, or for that matter, that they evaluated the effectiveness and appropriateness of their placement policies on an annual basis. But what was also quite interesting was at the school level, there was a lot of variability in terms of how people are thinking about their work. And it appears that quite often schools aren't using all of the information that's available to them to try and inform these important decisions. So for instance, the most popular we asked math teachers about a ton of different things, about the kinds of criteria they use to place students into Algebra 1. So are you looking at prior academic performance, prior CST scores? Are you asking about teacher recommendations, parent and student perspectives, basic skills placement tests, and so forth? The most popular sources of information were students' prior academic performance and CST scores, perhaps not surprisingly. But what's more interesting is that even though these were the most popular sources of information, these were reported strongly and consistently by math teachers in less than 60% of schools. So there's still a fairly large group of schools that aren't using this information in a clearly very intense and well-coordinated way. So this was one interesting set of findings in terms of, is there room to grow, to think about this carefully, to think about this with nuance, and so forth. Now, Mary also mentioned that what we had done in the previous study was basically try to say, what practices set apart higher performing schools from lower performing ones, given that they serve similar students. And we did a similar but more targeted analysis at the end of this. What we did was we said, other things being equal, are there particular practices that appear to set apart schools with higher 8th grade math achievement, as measured by general math and Algebra 1 scores? Accounting as best we could for the differences we could see in placement after using that longitudinal data file to control for prior student achievement and so forth. And what we found, and I'm just giving you a quick sampling here, is that other things being equal, schools that had higher 8th grade math achievement more extensively, more intensely did such things as focus instruction on key content standards, perhaps with teachers collaborating to break down the state content standards, such as to identify prerequisite student skills. This was something that showed up, the principals, the teachers reporting. This is a focus for our instruction, how we get on the same page. Emphasizing and setting measurable goals for student achievement by grade and subject across all performance levels, so not just getting people from basic to proficient, but from far below basic on up. Across all performance levels and in Algebra 1. And taking students' prior CST scores into account when placing students into general math courses in grades 7 and 8. Connected with that, it's interesting to note that in the original study we did, one of the other things we found was in a multifactorial approach. So taking into account more sources of information more intensely was also associated with higher school achievement. Now, these things are interesting in and of themselves in terms of what kinds of things appear to be setting apart higher performing schools. And now I'm going to move from findings into interpretation here. One of the things that really struck us when we looked at the body of these things, particularly things like focus on selected key content standards and so forth, is that a lot of these things seem like the very kinds of practices that could possibly enable districts and schools to carefully evaluate their approaches to placement, get on the same page about what are our goals, what do we think we're doing, how do we know when somebody's ready for this or that content, and so forth. For example, it's hard to meaningfully evaluate student preparation for different math content without a shared understanding of how key skills and concepts do build from one grade to the next. What are you looking for? How do you know? So this was another sort of hint that we were getting in terms of what might sort of help people get some more purchase on this really complicated issue of Algebra 1 placement, for which, frankly, unfortunately, we have no answers. But we've got some great questions and some interesting perspectives on it here that can perhaps enrich the conversation. So I'm going to turn it over to Mary to talk about some of the implications for schools and districts.
It's always frustrating when you do research and you end up with more questions than you started with, but there we are.
It's always the case.
Yes, it always happens. Start to peel back that onion. But what we do feel we learned from this study that we can share with the folks who are doing the work out there are some broad generalizations as you think about student placement into algebra. And one of them is that prior student achievement ought to be front and center in considerations of student placement. But beyond that, the nuanced decision-making about what kids should take algebra, with what supports, under what conditions, and how to make sure that they're ready for that success by the end of 7th grade is really an important exercise for schools to do. And we know that there hasn't been as systematic an approach to that as there might have been. Further, we aren't sure about what the best situation is for kids, especially that middle group. So it's really important for schools and districts to evaluate the decisions they've been making. Use the data you have at your disposal and really look at, did that work? Oh, when we put Johnny in 2 periods of 7th grade math, he was then really ready for algebra. Or if we had this extra intensive algebra instruction for these kids who we knew were kind of marginal, it worked. And they got through it and they succeeded. I would really love to be able to find out what happened in those schools where those kids really exceeded the expectations. That's very interesting stuff. The other thing is we have a new set of standards. The Common Core has been adopted. And that really provides a good catalyst for talking more about these issues and also staying informed. And it's really an extra opportunity for schools and districts to step back and ask important questions about the curriculum leading up to 8th grade math. So, you have copies of the study, or the policy implications of the study here. This is actually a summary. There's a full study document and a ridiculous number of technical appendices on our website if you want to get more deeply into what we looked at, what we learned, and what we didn't learn. And a quick commercial, we are also going to be publishing an action kit that is related to the full middle grades work we've been doing. And its goal is to help school teams, as well as district teams, think about what we learned, put it into the larger context of their work, and see the places where it might apply. And so we hope that the work we do helps to inform yours.
Thank you, Mary and Matt. So you've heard the study, and what we're going to do now is we're going to ask the panelists to react with a few comments. So each one will have about 3 to 4 minutes. And then as you have questions, there are little, could you hold it up, Bob? They look like this on your table. Please ask a question, pass it along to the left if you can. We'll pick them up and then we'll make sure that we'll get them to the, we have one already. All right, everything good. Thank you, makes my job easier. So before we get to that part, I'm going to introduce everyone and then I'm going to ask them to come on up and make their presentation. So the first individual I would like to introduce to you is Neil Finkelstein. And you have this information, so in the interest of time, I'm not going to go into a lot of detail. I will say this, Neil has a strong partnership with us right now here at the Foundation. He is a senior research scientist at West Ed, and thank you for being a copy of your study. So this will be available to you. Neil is extremely knowledgeable in this area and study of course-taking patterns, and he's been a terrific partner in our work here, so thank you for being here today, Neil. Next to Neil is SVEF Berman. And SVEF, if you read our blog, SVEF is very active in our blog. And he is, most recently was a chief software architect with Monolith 3D. But as far as his credentials here today, served in the 1997 Math Frameworks Committee, the STAR Mathematics Assessment Review Panel, and was a member of the 2010 California Academic Context Standards Commission. He's particularly interested in math, so thank you for being here today, Zach. And next to him is Steve Waterman, who is a retired superintendent who's not retired. He was at Brisbane for superintendent 1993 to 1998, and I think you're doing a little interim right now, are you not, Steve? And Steve published his Pathways study, which should have right here so I can read this off. His study was Pathways Report, Dead Ends and Wrong Turns on the Path Through Algebra, which studied the issue of placement and the ramifications of this very issue that we're talking about today. So he will be speaking to that as well. And then finally, at the end, we have a sitting assistant superintendent of Science Unified Chris Funk. So he's the practitioner here, an outstanding administrator, was the principal at Lincoln High School. When San Jose Unified moved towards the AUG requirements as the fall curriculum. And so Steve will be responding as someone who has to grapple with these issues every day. So at this time, I'm going to ask Neil to come on up and kind of get us started. So, Neil.
Thank you so much, Manny, and thanks for having me here today. Great to share this important topic with colleagues, and I hope we'll have some good time for questions, so I'll be very brief. I want to move the conversation that Mary and Matt started into sort of the implications for kids when the algebra decision sort of either goes well or goes less well, and what the implications are for students as they move through. I'm going to break with tradition and move with the mic. I have always wondered why the patterns of post-secondary access are the way they are in the state, and have wondered about this for years and years. And since I've been a little slow to the punch, Mary and Matt sort of figured out that it was middle grades math we ought to focus on, and it's taken me 20 years to get there. But nevertheless, the graph you see ahead of you are the estimates done by the California Post-Secondary Education Commission on who meets minimum eligibility standards for access into the public post-secondary institutions set out by racial categories. You know, if you look at the dark blue bars, those are for the University of California, and the brighter blue for the California State University system. And to say that there are racial disparity between the groups is very obvious. Certainly looking at the Black and Latino groups on the right of the graph, you see radically different patterns of minimal eligibility compared to the white and Asian students. So as a state, we sit in a place where the context of performance around minimal eligibility for post-secondary access is a live and vivid picture. I'll only add one editorial comment that these patterns have been so stable, and you could look at this pattern for the last 30, 40 years, and every 5 years it's mandated by California law to produce this, and the patterns do show up as being remarkably consistent over time. So what's going on? Well, to be minimally eligible is simply a pattern of courses that you take and doing minimally well. So math is, of course, one of those courses, and you'll see in this cascade chart of what does it take to get through the A through G pattern. Well, you better start out as a 9th grader on the left-hand side, minimally taking a math course. I have Algebra 1 there, one English course, and some other A to G course. It could be an elective or visual performing arts. And as you move your way from left to right, from 9th grade to 12th grade, you stack the courses one atop another, and by the end of the 12th grade, if you've gone on this very linear staircase, you've ended up completing the A through G requirements. And if you've completed them with a C or better, you've met minimal eligibility requirements for the CSU segment and a little bit higher grade point average for the UC system. So it's not a complicated, in a sense, it's not a complicated map in order to meet minimal standards. So what has to happen? You need to pass the courses, as I've said. So I just want to show you what happens in 9th grade algebra. For those who have seen me talk about this slide, I apologize. It is my favorite slide ever, and so I walk around with one slide. And I think it builds so nicely off the comments that Mary and Matt started us with today. So I want to look at math, and this is all about math. The upper corner on the left is about 9th graders, you move to the right, it's about 10th graders, you move to the bottom left, it's 11th graders, and finally it's seniors down here. And what are they supposed to do? Well, in 9th grade, if you go back to my staircase, they're only supposed to do one math course right? I mean, Mary and Matt have talked about Algebra 1 as an 8th grader. I'm talking about minimally passing Algebra 1 by 9th grade. And there's a little tiny number 1 on the x-axis, and above it, there's the number 50 way up at the top. I don't know if you can see. It's sort of, that's what I'm talking about. The point is, to the left of the bar, there are 42% of the kids who didn't do it. 31 plus 11%. 42% of the kids couldn't get through their 9th grade math course with a C or better meeting minimal eligibility standards. So the consequence of not meeting those standards in 9th grade are enormous for your completion of A to G. What happens when you get to 10th grade? My second favorite slide. Well, you add up from left to right again. 16 and 7 is 23, 23 and 19 is 23 is 42, and 11 is 53. So 53% of the kids have fallen off this math trajectory by the time they're a sophomore. So you get to a place, well, what does it mean as the kids migrate all the way through high school? And this is taking all course requirements for the CSU. And you find that by 12th grade, looking at the lowest line, these are African American students, and only about 10% of the kids have met their minimal eligibility patterns. It's, of course, differential by race and ethnicity, and then all lines slope downward, which is the kind of graph researchers hate the most. There's really no good news here except to say that people start off okay, not doing so great perhaps, but it's an incredibly steep fall off to meeting eligibility requirements for public post-secondary education. So this predicts differences in API scores. High API scoring schools do better than lower API scoring schools. The report is over there if people are interested. I won't spend more time. But the point I get to is the point that Matt and Mary get to, which is that we're testing in ways that sort of don't really move people further into the instructional conversation. And I only want to leave with one point, which I'm really delighted to follow your comments with, which is the reason students don't perform well in math is because they're struggling in math. We can have a long debate about whether or not being able to simplify the equation, choice A, B, C, D, or E, on this slide is a reasonable expectation for students to be asked to do. But we're so able now, with diagnostic testing and lots of formative feedback and lots of benchmark assessment, to learn very early on where the kids are struggling. And I think consistent with your comments, learning early about how students are doing in math in these basic skills around fractions and proportions and handling rational numbers and integers and symbol recognition, the kinds of things that students really struggle with in the classroom. You walk into a classroom and ask students to look at remapping a number line to a fractional pattern, or ways to distribute functional notation that are sort of solving and systematically working through simplification exercises. The struggles are very, very early on, and the proficiency patterns that we see really, really do show up early. And so my message is the 8th grade question and placement is related to an early diagnostic process, and I hope you've understood from just a couple of slides just how critical it is for us to see the consequences of not getting those decisions and distinctions right for students' access to public post-secondary education. Thank you.
Thank you, Neil. I'm going to ask Zev to come on up and we'll get your.
I was very pleased to be invited, obviously, and I was very pleased with the study that ESOS did. I think it was an excellent study, very interesting also. To me, the most striking part was the difference between different schools in assignment to algebra and grade 8 based on achievement in grade 7. The difference between the cautiousness of high achieving school versus the recklessness, if you wish, of the less affluent school is striking. And why is it happening? This is a question for speculation, for further research. I am not a researcher, I'm more of a policy person, if at all, in education. So I will speculate. That's what policy people speculate. This is a chart from around 2003, which shows basically the fraction of students, as you see, it's from paper written in 2003, it uses 2001 California data. And this is what we would expect, you know. Not everybody can take algebra, right? So here's what happens in grade 8. We put 100%, the numbers drop down. We put very few, 8, the numbers are high. That's what one would expect. Would one? By the way, interestingly, on the lower left, you have San Diego. Those are various cities in California, and then San Diego had this policy in the early 2000s, place blindly everybody into algebra. Supposedly, that was supposed to give them extra points on the API. I guess the governor rewarded the superintendent, making him Secretary of Education. However, it didn't work so well, as you see. Anyway, this is just this year's results from Palo Alto. 3 middle schools, affluent, very affluent town. However, we do have about 10% quite weak students, many of them coming from East Palo Alto, but many also living inside Palo Alto, not East Palo Alto. So we do have our own 10%, maybe 15% of weak students. And there are 3 different schools, and what's striking to me was the fraction of algebra taker by grade 8. As you see, JLS takes 52%, while Thermal takes essentially 100%. There's one student that didn't take it for some reason. And they're all doing very well, but you could say that JLS is creaming. Just put only half of the student there, and yeah, they had no basic or below basic, but guess what? Half of the students don't get to take algebra, but we don't know. But this is, you say, Palo Alto. It's a matter of affluence, a lot of money. Well, interestingly enough, I didn't prepare a chart, but 5 years ago, or so, maybe even more, but certainly 5 years ago, Jordan Middle School had a policy very much like JLS, in fact stricter. They would put only 30% of students into algebra and grade 8. They actually discouraged students from taking algebra. They would hide the criteria for the 7th grader, what it takes to get into 8th grade algebra. They didn't want to publish them. We don't want to pressure the kids. 5 years later, policy change, no more money, in fact probably less money on the average, comparatively speaking. You see the result of Jordan. Very respectable results. So you can have essentially 100% of students in algebra successfully. No, there's always a fraction, there's a small one that we take care of. Another example, not Palo Alto. Japan in early 1990s had essentially 100% of the cohort taking middle school, in their case lower and high school up to grade 9, that included algebra and geometry by grade 9. And they were essentially all successful. Not everybody was doing perfect, but the whole cohort took it successfully. So the previous picture, this one, yes, it reflects certain reality, but it doesn't have to be this way. It's not made by nature. Just very quickly, these are numbers of CSU graduation rates and enrollment on the bottom. Over the years, the cohort started in the year on the horizontal axis. As you see, the numbers have been rising over the years, which shows that overall, policy-wise, the policy seems to be working in California. Not as good as it could be possibly, but overall it's working. This is general freshman, general graduation. Then, here are the freshmen that entered its declaration of STEM direction, but did not graduate as STEM. The numbers are higher in terms of graduation, but lower in terms of enrollment. Finally, you have the case of people that enrolled as STEM and graduated as STEM. And those are even lower numbers, but all of them are going up. This is quite positive, very significant. Finally, I wanted to share with you one more point, because there were a lot of questions sometimes about what does the California standard test actually test? Is it a smart test? Is it a dumb test? It's only one test we have. Yeah. So what does it measure? There are tests and there are tests. Some tests are trying to figure out how smart is the kid. It's mostly psychometric test, if you wish, more than knowledge-based test. STAR test, the CST, is not like that. It's a very straightforward test. If you learn your basics, you can handle it. There are no tricks. And we are very careful. I have been working with the STAR assessment review panel since its inception. And when any question that is tricky question, we tend to kick it out. We don't want tricks. We want straightforward. People accuse us, oh, it's dumbing down, it's dumb. No, the purpose is not to trick, not to see who is the perfect, who is the better than the other one. The purpose is, did we teach you the basic things so you can handle it? I have two examples here. This is from Washington assessment test, which is much more intricate test, supposedly smart. However, if you read grade 3, I don't know what the answer is. I know what they want us to hear, or want us to say. They want about the 7, 3, 5, 7, sure. But what about the size of the stamp, the size of the row? The next one will be 9. When will it stop? Clearly it's a stupid question, ill-defined. There's no correct answer. Any number is good. Maybe he left the next row empty, who knows? What about a grade 5? Again, you can actually deduce the answer here, but it's pretty complicated, and it's not straightforward. Some kids will do it quicker, some kids will do it slower, but it's very hard to say by the end of it whether the slower kid necessarily doesn't know math. He's just slower with kind of tricky questions. And this is even worse in grade 11, grade 10, where the kid really had to trial and error. There's no math here. The math here is 4th, 5th grade math. Just plug the numbers, compare, run it. There is no math here. It's 10th grade test, but it's complicated as hell. If you start the wrong direction, it takes you 10 times longer than if you were lucky or smart and started the right direction. There's nothing to do about math. It's to do about general smartness. These are STAR examples. STAR example. Very straightforward. Oh, this is dumb. No, this is not dumb. This is straightforward. Clean doesn't imply knowledge of the language too much, so we don't penalize English learners. It just says, yes, you know your stuff at normal level, and that's it. One last word that I wanted to leave you with. the issue of Common Core was brought up at the end. It's important, in my opinion, and I can show numbers later on, we can discuss it, to start with algebra early. And there are various reasons. The research mentioned a focus on key standards as a good tool to focus on preparation. However, Common Core is no key standard. It's just a flat list of standards. So what to focus on, what not to focus on. California was lucky, or not so lucky, smart maybe, when it identified what are the key standards. In fact, Common Core does not by default assume teaching algebra in grade 8. And this is something people don't mention. I'm done.
Let's get, because I have a question on Common Core, so that way we go.
Sure.
Thank you, Zev. Steve?
Thanks. So I'd like you, first of all, I need to tell you that I'm like the last bleeding heart liberal probably standing in the room. And I've worked in mostly minority districts my 40-year plus career, and I'm a big advocate for algebra in 8th grade. So you need to take that into account. So I was really impressed with this study, and I was particularly impressed with the chart on page 3 of the study. Because to me, it was like this great indication of the success of the initiative in California to encourage kids to take algebra. The initiative resulted in nearly a doubling of students enrolled in algebra and more than a doubling of students scoring proficient, greater access and greater success. To me, it hints at the potential of our students to accomplish much more than we've ever given them credit for. It was done, and this huge increase in the number of kids who were scoring proficient in algebra was done without extending the school year, without negating teacher unions, and with less money every year. I mean, it's really, to me, an amazing tribute to the fact of the potential of our students. For economically disadvantaged children, it was even more dramatic. 3 times as many students took the test, and 4 times as many scored proficient. There was 40,000 additional low-income students passed algebra in 8th grade in this study. I mean, to me, that is just an amazing symptom of what we could do in our state. Moreover, with greater access to students we usually consider to be less prepared, the percentage scoring below basic actually decreased. The chart on page 6 illustrated to me the possibility of another educational quandary. Most of the students who were unsuccessful at grade 7 were unsuccessful at grade 8. But the lack of success in grade 8 occurred in both the 8th grade test and in the algebra test. Actually, to me, it's amazing that 11% of the kids who had scored below basic in 7th grade actually scored proficient in algebra. And it points again to the problem of using any single assessment as an indication of what's going to happen. And when my study I looked at, in addition to the CST, I had access to student grades. And what I have today, I've been working with 5 school districts in the North County in trying to come up with a standardized approach to placing kids that would use what people call triangulation, more than one measure. And this is like the latest information from this spring. And it gives you the number of algebra students recommended for algebra and geometry. Now these are kids who are taking algebra in 8th grade, and what teachers, even looking at systematically prior test scores, what do they recommend for kids next year? And you can see that overall about half of the kids who are currently in algebra in those districts are being recommended for geometry next year. And
could you make that a little bit bigger?
actually, I'm incapable of doing things like that. Maybe the tech person can do it. I really don't know how to.
PDF file, so just put.
Help yourself.
I'm not
Please.
a Windows
Sir.
person.
Neither am
We'll try
I.
to get that for you.
Okay. in any event, if you looked at kids who had grades of B or better in the mid-semester, 77% of the students were being recommended for geometry, but still 23% of the students are being recommended to repeat algebra next year. And a couple years ago when I did the bigger study, the pathway study, the number was even more dramatic. And what I found was those students who had B or better in 8th grade algebra were placed in algebra again in 9th grade. Half of them had grades below B the second time around. So this whole issue of the arbitrariness by which we decide as adults which children are potential, have deserved to do algebra, deserve to get into geometry, earn geometry, are equal to the skills of geometry, that those decisions that we're making have huge ramifications for kids. Thank you.
I'm gonna ask,
I'm actually, before Chris comes up, I'm going to ask Chris a question so you could fold it in, Chris, kind of right off the bat here, and we can get into some questions. So, Sansa Unified moved towards a selective process to placing everyone in algebra. What has been the result of that in Sansa Unified as far as the student results that you've seen since that policy decision was made?
You want to answer from here
you
with
can
my
do it, if
teacher
people
voice?
can hear you, whatever, right. Although I think,
Okay, I'll come up
this is
here.
over so they can get the,
Sure.
So a couple things before I get to that question. So San Jose began the journey through A through G back in '99 with our first graduating class in 2002. And what I like about A through G, even though it's a simple progression and 15 minimum classes you have to take, it allows every student the opportunity when they enroll in a high school, in any high school in San Jose Unified, for them to be on the path for acceptance to UC-CSU without some administrator, some counselor choosing the path that student's going to go on. And so in order for kids to reach those opportunities, and it is about opportunities, it's about the opportunity gaps that lead to the achievement gap. And it's talking about the oppressive system that we have in place in the United States that we've had in place for the last 4 decades, 5, 6 decades, where we do not allow kids of color the opportunity to be successful. A through G allows that to happen. And in order for kids to be successful in high school, the opportunity for them to start taking algebra in 8th grade is critical. And so for us, most of our 8th graders are in algebra. And if you just look at the last 3 years, 3 years ago we had about 1,000 students enrolled in algebra. Only 37% of them were proficient advanced at the end of their 8th grade year. Last year we had 1,800 students enrolled in algebra in 8th grade. The percentage lowered to 31% proficient advanced, but the number of kids increased that were proficient advanced from only 470 kids to 592 kids. And so the more opportunity you give kids to perform and be successful, the better off they're going to be and have the opportunity to reach that cascade of A through G. We look, and the report hits it right on the nail. You need to look, we look at 2 years of CST data. We look at our benchmarks of the current year, how well the kids did before we place them in algebra in 8th grade. We also determine in 7th grade whether or not they're going to be in a pre-algebra class, an algebra readiness class. We do have some 7th graders in algebra. We have approximately 90 to 100 students that take geometry in 8th grade. So it's looking at different data points. It's looking at your benchmarks throughout the year to see how well the kids are progressing. It's your grade level teachers looking at those assessments after each benchmark to see where the gaps are to determine whether or not they're going to reteach some of those standards. And it's about that vertical alignment. 2 years ago when we did our math adoption, it's the first time that we forced all high schools and middle schools to have the same math textbook. It's amazing. San Jose Unified all those years, even when I was principal, we had 3 or 4 different algebra books in high school. But we had a mobility rate within our district, intra-district mobility rate of 18%. So you'd have kids going from one school to the next and having different algebra books. And so when we did our math adoption last year, or the year before we started last year with it, all high schools have the same algebra, geometry, and algebra 2 textbook, regardless of the school. All middle schools have the same algebra book. All middle schools are using the same algebra readiness curriculum, the UCLA curriculum. And so it's that alignment that is critical. And I think the next step for us that we have to do a better job of is making sure that our 5th and 4th grade and 3rd grade teachers who have their multiple subject credentials and don't tend to be specializing in math, we need to bolster their content knowledge so that the kids are getting the early algebraic terms early on, mastering them so they're going to be successful. I think the one area that I like to see someone do a report on, study research on, is though, is there a correlation between kids that enter as freshmen in college who have to take remedial math? Is there a correlation to when they took their last math course in high school? Because in San Jose Unified, you're taking geometry in 8th grade, and now you have 3 years of math that you have to graduate. What happens if you're done in Algebra 2 or pre-calculus or calculus and you haven't taken a math in 2 years? Or you haven't taken math your senior year? Is there a correlation to now you have to retake your remedial math in your ninth grade, your freshman year in college? So that would be a great study that I'd like to see done. So Manny, with that, I'll turn it back over to you.
If you could move your chairs up so we can, because the mic can only go so far, so we can get rolling on this thing. Thank you.
So thank you all for your comment and reaction to the study. So we're going to just start off with some questions. And I'll ask you to try to make them as brief as possible so we can try to get as many. And Steve, I'm going to start off with you. Your studies show that many students, if I recall, like 65% who took algebra in 8th grade had to take it over again in high school. What do you attribute that to? What do you surmise or you found out in your study?
I would certainly wish I knew the answer. Most of the time, it's the one kind of decision that teachers really have an enormous amount of power in our system. And the teachers make those recommendations. I think in some cases, and maybe this is one possible explanation for the findings in the middle class schools, the 8th grade teachers are terrified that they're going to send a kid to geometry into the 9th grade high school district, and the high school district people are going to say, hey, you're sending unprepared kids to us. So they strive to make sure the kids are super prepared. I think in other cases, kids are graded based on their homework or whether they cooperate in class or for all kinds of other reasons. And and frankly, I think that sometimes we think that we're making a good decision, that we want kids to be successful. In 9th grade, it's a big transition, it's a change, and why put a kid through having to struggle in a new course when they could be more successful retaking algebra, and then they'll be really strong. Unfortunately, it doesn't usually work that way, but I think those are some of the good motives.
If I recall, a part of your study also found that teachers do not use the success in current algebra, 8th grade algebra, before assigning in the 9th grade. And wouldn't that be a major issue, that they just ignore the data?
Well, as everybody knows, the CST results don't come out until now late July, or it used to be early August. So placement decisions have already been made, and people are guessing based on the best information they had at the time, and they tend to underestimate.
So, Zev, I'm going to ask you the question that you were starting to refer to, and what do you see as the implications of the Common Core standards relative to this whole issue of algebra in 8th grade?
Maybe I should preamble this, preface it with a statement. A couple of years ago when Common Core started, I thought it was a good idea, and I worked pretty hard to make them better. I published some report on the subject, and I think I did make them better. However, since then, in the last half year or more, almost a year, I came to a conclusion that the idea of Common Core is flawed at its foundation. Having said that, let me go to answer the question, because I'm biased. That's what the reason for my preface. So don't take me as completely objective. You can claim, well, he has an opinion. Yes, I do. Now let me tell you the facts as far as I know.
That's why you're here, so you can express your.
Okay. Common Core, by its nature, the way it's done right now, does not assume algebra in grade 8. It makes pre-algebra with a minor plus as a target for 8th grade. This is in opposition to what the National Mass Panel found just a year prior, or a year and a half prior to the Common Core, so, which the National Mass Panel did recommend algebra in 8th grade. How to reconcile it? Well, California made a solution which basically put essentially all of algebra content of California, which is a decent algebra content, on top of the 8th grade Common Core, which is pre-algebra with a minor plus, as I said. So now you have a double load, or double whammy, in the 8th grade, if you choose to take it. How it will impact the California achievement if we indeed go and implement it, I am quite fearful, because I see that because everybody follows the same path through grade 7, based on Common Core, which doesn't prepare them for grade 8 algebra, it prepares them for grade 8 pre-algebra, essentially. Now you say, well, you have an option in grade 8. You can take the regular Common Core, which is pre-algebra plus, or you can take pre-algebra plus algebra, double whammy. How many of you really take it? I think the racial and the income gap will just explode, and the number of takers will drop, because those that will take external tutoring, external preparation, will take it, sure. They have parents, they have tutors, they have money. The others, hey, they just can't do it. That's my prediction, but as I said, I'm biased.
So given that, and I'm going to ask, Neil, I'm going to ask you to respond first, but Steve, this kind of ties in your study, and Mary and Matt, feel free to weigh in on this. So given your study in course taking patterns, which you alluded to, your placement work, Zev's comment on Common Core and the impact on demographics, what do you think all these issues relative to placement, either paying attention or not paying attention to them, have on students of color? And you kind of alluded to it in terms of your course taking patterns, but Steve, I'd like you to kind of weigh in terms of what you found out in terms of your study, and I don't know if Mary and Matt want to weigh in on that as well.
There are two parts that I'll take apart. One is building off one of the recommendations from the EdSource study, which is, they see a very clear and systematic increase in accountability measured results where districts and schools and leaders pay attention, and it's a pattern of instructional leadership, undoubtedly, that sort of follows the accountability metrics. So there seems to be no question in my mind that kind of leadership that follows current California standards well will now follow Common Core standards well. What I would look to, if you had to forecast, and I understand Ziv's reservations, are the implementation of instructional approaches that are much more closely aligned with the Common Core as they're now put forward. I think we'll see an enormous amount of hesitation, reluctance, flailing around, frankly, waiting for there to be implementation done locally, done regionally, done statewide, done by private vendors, done by public support agencies, done by all sorts of entities who are now trying to understand what it means on the instructional side. So Amanda, your question was, well, what's the implication on students of schools with different performance patterns historically? And I would probably say something that all of us together might agree on, is we have less experienced and teachers who have not gone through reforms and cycles of standards-based changes over the years with less ability perhaps to be adept at the implementation of new and effective instructional approaches as the standards roll out. So, I would join a group of colleagues, I think, who share some hesitation and reluctance at the speed with which the Common Core is being implemented, and nevertheless, it's a way to move forward. And if you think about the problem nationally, California has had over time a remarkable high set of standards, and that's not been the case in many other states. So we'll have some growing pains. I'd like to say that I'm optimistic overall, and I think the instructional approaches as they apply to high-performing and low-performing schools will have to rise in all cases over time.
I think my study found that in integrated schools, that minority students by and large were less often given access to algebra, and with the same grades, less often recommended for geometry. So I think that those implications about social justice really do affect algebra. And in my opinion, the kids who struggle with English language have the best prospect of being able to get into college-bound classes if they take algebra in 8th grade because of the way computer systems program you in high school. Because geometry is a singleton required course, it's the first course that you get scheduled for. You then get, the computer will most likely automatically schedule you with other academically inclined students for your other courses. So that access to geometry in 9th grade becomes really the key to get involved with a whole different group of students, and the ability to be able to finish calculus in high school, which gives you easier access to half the majors in college.
This is a question I have here. I'm going to ask Matt and Mary on this, but Chris, if you can also follow, because you kind of started to talk about what you're doing to help prepare your elementary teachers. And this question is, in the study that you conducted, what survey questions did you ask that would give you an idea of teacher preparation, standards aligned instruction, and supervising instruction that would ensure high quality instruction? Do you recall any questions that you might have asked?
We had over 900 survey items. We asked about almost everything. And
Could you
what...
mention 50 of them?
Yeah, I'll just reel them off. Actually, if you go look at the original study, you'll get a pretty good sense of it. But what the study itself does is to highlight those things, again, that differentiate higher from lower performing schools. And so there might be something that is true for everybody, like all of our 8th grade algebra teachers are fully credentialed and in single subject. And if that was true across all the schools, it wouldn't show up in our study as differentiating. It wasn't true in all the schools, but it didn't show up, if I'm remembering correctly, as differentiating. So you can go through, and some of the things you expect to see, you won't see, but there are also some really interesting ahas in it, and that's part of what we're really excited about, this playbook thing that we're doing that'll really boil down what the stuff was across the whole study. And hopefully make it really accessible.
We did ask lots of questions about credentials, things like that, sort of people's highest level of education, their number of years in the classroom and so forth, also of the principal and things like that. Those things, by and large, didn't show up, but the kind of things that did show up, this wasn't a study of pedagogy, this wasn't going and observing classrooms or having any particular ideas or even trying to figure out if there are best practices in the classroom. But the kinds of findings and things that sort of stand out in my mind here that are very much around instruction have to do with is there a shared and intense focus on sort of what the key standards are, what you actually are paying attention from one grade level to another? Is there more intense time and availability for collaboration around things like lessons that did and did not work, around how instruction relates to common benchmarks, what are the common benchmarks, things like that. So where our findings are really rich, I think, are in terms of not just what are the infrastructure, are there standards, or are there curriculum, but what are the everyday the everyday practices that actually make those things meaningful and put them to work on behalf of a learning, continuously improving organization. What that doesn't give you is what's going on in the classroom. But it at least gave me a sense of sort of what is the spirit and the tenor of all the work and all the collaboration going on around the classroom, and that in fact not only is it happening, but it's happening more intensely. So I think that's where we offer some value, but pedagogically, we didn't try to get to that.
Chris, do you want to add more to what you're doing? As a unified district, you have the advantage of being able to articulate K-12. Elaborate a little bit more in terms of what you're doing to help with that articulation.
Well, I think it's critical that you backward map what you want all your students to have, what skill set you want, what standards you want them to have mastered from one grade level to the next. Excuse me. We have a pacing guide for all of our teachers. It's not a pacing guide that every teacher will be on the same lesson every day, but in between our interim assessments, benchmarks, are the standards that they have to cover. They're the heavyweight standards. They're the standards that we know will be asked most often on the CSTs. And we have weekly collaboration going on at all of our sites. And it's around looking at the student data, and it's around informing your instruction. Two of our key initiatives this year that we started was direct instruction. So every single teacher, we started with elementary, so every single kindergarten through 5th grade teacher came in for 3 collaboratives around direct instruction. And then the second initiative that's tied to that is instructional coaching. Because we believe the change that's going to happen and eliminate the achievement gap is that one-to-one relationship between the student and the teacher, and the instruction that's going on. And whether it's your top performing teacher or your first year teacher, all teachers need someone working side by side them to give them the opportunity to reflect, for you to model, for them to watch, for them to model, and you to watch and give feedback. So direct instruction, instructional coaching, the use of heavyweight standards, and the use of data and common benchmarks. All of those are all the things that we're trying to implement and align in Sounds Unified.
Thank you.
We still have a ways to go.
I'm going to ask one final question, given the time. And for those of you that have questions, please come up if the researchers are willing to stick around. There's a couple of questions that are directed. But here's a question that I struggled with as superintendent. I'd like to ask each of you to respond to this, and any final comments that you want to make on this. And that is, given the challenges districts have to face, given this issue of placement, what would you consider, I don't want to say that, the worst transgression or the better way to go? If it's a student who is placed in algebra and is not quite ready, or a student who should be in grade at algebra and misses the opportunity to take it and then is off on the cycle. So I'm just going to throw that out, and I don't know who wants to try to take that first. I struggle with it, so I'm going to...
I'll go first and be brief. My answer to your question, Manny, is the distinction between algebra or non-algebra in 8th grade is too coarse a distinction. There ought to be a way to know what the students are strong in and less strong in diagnostically, and provide instructional support in the areas where they need reinforcement and move them on their way quickly. So it's an early diagnostic with differentiation and modularized instruction to move students along just as quickly as they can.
Well, this actually jives into what I wanted to mention. This is exactly what should be done. I agree with you, Neil. And in fact, California recognized it 3-4 years ago, and it prepared a bunch of algebra readiness programs that are exactly supposed to identify the areas where a student is weak and lead him through to success in algebra. It was approved. We approved the textbooks. We pushed the publishers to prepare them. We approved them. And then, on one hand, budget cuts happened. On the other hand, common core standards happened. And all these books, all these wonderful programs, some of them really wonderful, I looked at some of them, are sitting on the shelf. Nobody's buying them because there's no money. Nobody's pushing them because, hey, we are leaving the standard soon, so why should we bother? But this is exactly what should be done. And we identified it, and we did something about it. And it's waiting, but nobody's touching.
I guess, like Manny, I have to make those decisions, and the option of doing it right isn't always there. So if I had a choice, and I do, I would put kids in algebra and expose them to the content. A lot of them do a lot better than we ever thought they would, and with a good teacher motivating them, we've had some really terrific success in my school district. So, I mean, we put all of our kids in algebra last year in 8th grade, and 61% of them passed the CST. And that's in a district with over 70% free reduced lunch. So it is possible, but it's possible because the teacher believed in it, the teacher worked hard, and you know, I think that's really what makes the difference.
Chris, I think I know the answer to this, but go ahead.
I agree 100% that I believe in access. You give students the opportunity to achieve, and they will rise to the occasion. Now, a big piece of that is having a qualified teacher that believes that kids who walk through their door will be successful. But it's the same with AP classes. The problem with AP classes is we set the standard at, you have to have this level of an entry exam, you have to have this grade point average to get in. But if you had open enrollment in your AP classes and you give kids the opportunity, yeah, maybe not all of them will score 4 or 5 on the AP exam, but just the access to the rigorous class is going to benefit them for the next year and when they enter college.
Thank you, Chris. Matt and Mary, you get the final comments?
Well, I'm lucky to not be in a position where I have to make those calls. Well, and I guess in some sense, I'd just like to reframe the issue a little bit in terms of, you know, the transition from grade 7 to 8 is this one pivotal moment in time, but this is really a systems issue, and it's building on a whole range of decisions and practices that have been going on for years and years and years. And you know, it's not just the work that we did that raises concerns about, you know, by the time you get to the end of grade 7. The evaluation that Humbro did of the KC in 2009, they were looking at, you know, students that were struggling the most in grade 7, they were the ones that were gonna have a much harder time passing the KC, not just in grade 10, but by graduation time. And again, what is the KC in math? It's mostly grade 7 content, you know? So there's really no substitute for really thinking through very carefully and approaching this as a systems question leading up to grade 7. That decision leading up to grade 8 is only one moment, and I would just sort of encourage people to think about it in that way.
And I'm going to take the liberty of answering this question as a person who had 3 kids go through school. Because at the end of the day, they had different experiences. And access is really important. But access without a commitment to success ends up sending a message to kids who failed those 8th grade classes that they weren't ready for, or 9th grade, do okay in 8th grade and then end up having to take the class again and then fail, as Steve found. The message that sends to those kids about math not being for them, I'm a failure, I'm not going to be able to get through high school, ooh, I don't think I can do college, is devastating. And so I guess for me, it kind of echoes Matt's point. The work of getting kids ready for algebra is extraordinarily important. And it is less important for me as a parent if my kid is in that 8th grade algebra class than that when they take it, they soar. And so the system has to support them to do that. And if it can't do that, then it should not be putting them in those classes.
Thank you. Well, this ends our discussion. This is just the beginning. So we hope next year to have a longer conversation on this incredibly important topic, and one that I know I struggled with as superintendent, and I know that all the people that are involved in schools have to address this on a yearly basis. I want to thank my colleague Bob Nichols and Jill Winkelstein, who's not here right now, for the work involved with this forum. Thank you, Create TV, for your work. Again, the top head writers, John Fensterwald, Kathy Barron, please check out their blog. I have a feeling they might write about this.